we want to talk about the 7 segment and see what's the meaning of the 7 segment. So our title here is 7 segments. So remember, in chapter 1, actually, we introduced some coding, right? For example, we actually had the BCD code. So what was the meaning of the BCD code? We say, okay, for the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you could actually have specific codes for each of these numbers, right? We introduced some of them in chapter 1. For example, we had actually the BCD codes, and we say, okay, if you want to represent the 0 by a BCD code, 0 is 40 in the BCD codes. So the other actually example was actually XS3, right? So remember, we say, okay, XS3 is a coding system which it represents 0 by 0011, right? We call that XS3. 7 segment actually is, again, similar with the other coding system, is another coding system which you represent each of these 0 to 9 with specific actually codes. But unlike the XS3 and BCD, which is we actually represent each number 0 to 9 with 4 bits for the BCD, remember? So for 7 segment, actually, you use more than 4 bits. It is actually 7 bits. So that means 0, you represent 7 bits. So you call actually, you label each of these bits. I label that A, B, C, D, E, F, A, B, C, D, E, F, and also G. Just 7, right? You have 6, 7 bits. So I write the codes, then explain why we call them 7 segments. So the 0, exactly the same with the codes that we had for BCD XS3. This is just 0. The 0, you represent 0 with these 7 bits. So which is 1, 1, 1, 1, 1. You have 0 and 1. So how I could write these 7 codes somehow is easy to answer that question. So if I have the 7 LEDs, okay, so I have 7 LED, I put one LED like this, one LED like this, one LED here, one LED here, one LED here, one LED here, and one LED here, okay? And label each of these LEDs. So I actually label this, start from this one. I call this A, I call this B, I call this C, I call this D, and I call this E, and this is F, and these LEDs G. And suppose these LEDs, you actually connect the anode or negative pins of all these 7 LEDs to the ground, and you have actually 7 pins in the back of these LEDs, which is if you connect that positive of each of them to the 1, these LED will be on, and if you connect to the 0 volt, so definitely these LED will be 0, okay? So let's see why the 0 is 1, 1, 1, 1, 1, 0, 1 in actually 7 segments. So if you have these 7 LEDs, so whenever the code is 1, so that means you have 5 volt in on that LED. Okay, so if I connect these 7 bits to these 7 LEDs and they're negative connected to the ground, and the all other pin, which is the positive pin, connected to these labels, which I call A, B, C, D, E, F, G. So that means whenever you have A1, which is A is 5, 1 means 5 volt, right? So definitely whenever A is 1 is 5 volts. So that means for these LED, A, you actually connect the positive to the 5 volt, is negative connected to the ground. So definitely whenever this is 1 means these LED will be on, right? Similar with the others. Whenever you have the 0, the corresponding LED should be off. So let's do this for 0. So if this is a 7-segment codes for 0, if I have these 7 LED, let's see what it means. A, B, C, D, E, F, G is on, just F is 0. So I just turn them on. So that means A, B, C, D, E, and G is on, and just actually F is 0, which should be off. That means I don't have any on LED here. So what it looks exactly the 0, right? This is how you represent the digital numbers on the 7-segment. So that's why they got that name, right? So now you could actually somehow guess for 1, if you have 1, what's the 7-segment codes for 1? You tell me which of these 7 should be actually on or 1, which of them should be actually 0. Yeah, see, the D and E should be, yeah, that's right. The D and E should be on. So that means that I use the same color. So the D and E is 1, right? So the D is 1, this is 1, so the rest should be 0. So Y, this is Y. So if you actually just turn on, that means you just turn on D and E, the rest is 0, right? So this is D, this is E. So this is definitely 1, right? So tell me what's the 7-segment codes for 2? Which actually pins should be turned on for 2? Yeah, C, F, A, G. Yeah, definitely. So C, if I turn on A, if I turn C, right? If I turn D, and if I turn F and G and put the rest 0, let's see what's happened. So I write here. So I put I put A, which is, this is the A. So see, this is the A. So what else we have? C and D. So you have actually, this is C, this is D, okay? Then you have F, this is F, then you have G, right? So yeah, I made 2, okay? So this is 2. So that's right. So how about 3? For 3, just tell me which pins should be 0 for 3. For 3, which pins should be 0? Yeah, B and A, definitely. So you just, for 3, you just put 0, 0, which is A and B. The rest should be 1, 1, 1, 1, 1. So let's see if just B and A is off, the rest is on. So you have actually these 3, right? So you have these 3, okay? So that's right. So how about 4? For 4, I just put, yeah, let's just see, is it right or wrong? I put A is 0 for the 4, C 0, C 0, and also G should be 0. The rest should be on. Just check here. So see which one is off A. I don't have A, right? Next is C, no C. I could actually have here. So C, we have a B. We have B, right? So where is the B? So this is B. So then we have D. This is D, right? Then we have E and F. Where is E and F? This is actually E. This is F. And the rest is 0, right? This is 4, right? So if you turn on that LEDs, you have 4. Okay, that's right. So similar with this, you could actually take care of the rest. So if you just consider all of them, for the 5 actually is 0, 1, 1, 0, 1, 1, 1. You could check that on the LEDs and see is it right or wrong. So the 6 is 1, 1, 1, 0, 1, 1, 1. So 7 should be 0, 0, 1, 1, 1, 0, 0. So the 8, easy, right? 8 should be all of them. If you turn all of them on, it's actually the 8. And for 9, you just don't have these A, right? If that is 0 and all other is 1, you have actually 9, right? So see the 9. So if I just turn off this, whatever you have is 9, right? You could check the all others. So whatever you see here as a codes, definitely it's actually right, that numbers on that your 7 segment, which is the actually cool things, right? So maybe the one of the annoying things in our face-to-face lab was whenever you actually have, for example, you had the adder, you had the subtractor, right? You add two numbers in the binary, then you got the result, then that result won on the actually the binary again. In the binary, you actually convert to the decimal and see the subtraction or the add is right or wrong, right? But after this class, you should be able, you could actually have all that circuits and you connect the binary bits to the 7 segment and you exactly see that numbers on the 7 segment. So definitely you actually saw the 7 segment on the lab. So we have actually all these 7 actually LEDs is inside the one pack, and in the back of that you see actually eight pins. So one pins is the connect ground, which is you just connect that the ground, and other 7s goes to these A, B, C, D, E, F. So that means whenever they are on, the corresponding actually LED is on. Okay. So definitely this is our goal. Our goal is here, after know okay what 7 segment is, the question is how we could actually convert any binary numbers to these 7 segment. Because if I could do that, so that means whatever I have as a binary in any output, I could actually use these 7 segment and see that number in decimal on the 7 segment, which is actually more makes sense and it is more clear what you have as a output.